So good evening to my evening students. We are going to be working on the last step of 2-3. And I think we're going to get through everything we need to in 2-4. So the only thing that will probably be left off of 2-4 is an extension problem about blood alcohol. No. We're doing that one about a college student's weight gain and weight loss at college. And it's an extension problem, and I already made a video. So if you want to do those problems for extension, you can go to my YouTube videos, and it's lesson 2-4 part 3. So 2-4 has 3 parts in YouTube, and we should be able to get through both parts today. So
what do you mean extension?
Extension meaning it's kind of more of the same, but just more practice. So it's in asking similar questions, but it's just giving you more practice before you go do the worksheets and such. But if you want to try the worksheets, you know that first before you go and do those. But it's a really good problem actually, because it's about a linear increasing, looking at you guys, a linear increasing and then a decreasing equation. So, but we haven't really finished it in 2-3. So technically we don't know about linear and increasing and decreasing yet. So let's go ahead.
Oh, Brandy, I love your craft room.
Thank you.
She's all organized over there. Holy smokes.
You can come and help me organize mine.
Well, the house came with the shelves. It helps.
Awesome.
Oh, man.
I could use all those shelves.
I could use more.
Amen to that.
My husband puts up shelves and they're like 10 feet apart, and I'm like, what am I gonna pile in there? I need things that are smaller so I can put boxes and
Books and variety.
oh, but he just doesn't.
Mine are garage rated. They will hold a couple 100 pounds.
That's good.
Awesome.
Okay, 161, right?
Yep, so we're on page 161 to start. And we're starting with the cab ride. I don't think we've done this one yet. This is where we ended last time. Okay. So I'll let you ladies get it started, and maybe good to have Desmos open as well. And I changed the way JetNet looks, and I just made Darla's whole week.
Yes.
You can collapse all the topics so you don't have to scroll through all the weeks to get to the next week.
I wondered why it looked different, and I was like, do I like this or not?
Yes, you will. You will thank me. I promise.
At first I thought it was just like glitching, and then I'm like, do I just need to refresh again?
Well, it takes like 5 minutes to scroll where we need to be. Now it only takes 30 seconds. Okay, what are we doing? According to the taxpayer finder, a cab ride from the airport in Las Vegas will cost an initial $5.10 plus $2.60 per mile. Use the information to fill in the rest of the table describing the total cost for the various distances, and create a scatter diagram using just X coordinate and the cost as Y coordinate. I'm sorry, my Disney, I cannot watch you right now.
Sorry, what?
I have Disney up because I like all my Halloween shows. Well,
Okay.
let me mute this.
So is everybody have an idea how to fill out their table here for the taxi ride for miles 3, 4, and 5? Or,
My
yeah.
Desmos doesn't want to load, so I'm just a little distracted, but
Oh, that's all right. See if
my
I-
internet hasn't been working because of the one.
So I got the numbers.
Me too.
Okay, what'd you come up with?
1290, 1550, and 1810.
1290, 15, 15, and 1810.
1550, 1810.
Okay. Am I sharing my paper, I think?
Yeah.
Okay,
Yes.
just want to make sure. Okay, so we can plot these. So 0 and 5, 10. 5 is going to be just between the 4 and the 6. 1 will be at 770. I'm going to show you in Desmos real quick too. So I'm going to plot these quickly here. So 3 and 10, 30.
Oh, on how to plot them on Desmo?
Well, Desmos doesn't really help us on this problem, so we won't put these in Desmos. We'll just hand graph these just for the look of it. We can do everything on this problem without Desmos benefiting us, I should say. So
Okay.
3 and 12.
2 is 10, 30. 3 is 12, 90, somewhere in there. 4 is 15. That's okay, somewhere in there. 5 is 18, just past the 18. It goes up. Yep, that's what I got.
Okay, fabulous. So number 2 says, what do you say? What do you say about the graph? Once you connect the points, what do we notice?
Pretty straight line.
Pretty straight line unless it's Mrs. Means drawing. I hope it works out for me.
Same.
Well, the further you go, the
They
more
didn't
it
give you a
costs.
very precise chart either.
Drawing never works out for me.
So the further you go, the more it costs.
Oopsie. Okay. So yep, so it looks like it's a straight line. Okay, and we're going to introduce 2 points on our graph. One is the y-intercept, which is where we cross the y-axis. So this is our y-intercept. And then, so our y-intercept will always be when x is 0, and it will be the y value of that coordinate.
Up and down.
Yep, so x is 0, so no left and right, and then you go up to where the y, to where the line crosses the y-axis. And so in our case, it's 0 and 5, 10.
Okay.
Now, the x-intercept, so this is the y-intercept. Can you all read my blue pen, okay? Okay, the x-intercept is where the line crosses the x-axis. So if we extended the x-axis this way to the left, right? Then the line would have to extend back here somewhere. Are we gonna have one of those on this one?
No,
No. Why would it not have an x-intercept?
You have to go into the negative cost.
Right? And negative miles, right? It'd actually be negative miles. So no negative miles. So if we did have one though, it would be an x value when y is 0. So you're going to go left and right to where the line crosses that axis, but you're not going to go up and down at all. But we don't have one, like I said this time.
$260,
And
number 4,
the difference, the difference would be, oopsie.
$2.60.
Mhm.
Between them, yep, okay. And then what about for number 5, between a 5-mile and a 2-mile ride?
$7.80.
Everybody agree with that?
Yes,
Yes, I do too.
780, okay. 780, okay. Now.
it's a 3-mile difference.
Mhm. Now, number 6 on page 162, I'll let you work through that one and see what we come up with.
Okay. Pick any 2 points on the graph that you drew and subtract the second coordinates. Then divide the results by difference. Oh my gosh.
You got this.
Gotta make room for me to be able to write in the book. Okay, so pick 2 points, which I have them right there. Each person in the group
All
should
right, so-
pick their points. What does the results represent about the cab ride? So we're all supposed to pick a different coordinates?
Yeah,
Wait,
so I'm picking 1 and 4. I'm picking mile 1 and mile 4.
That's what I picked.
Okay, then you go with it. I'm not gonna put it up here yet, so you'll be mine.
I was like, let me get a circle. So I circled in purple which 2 I was
Oh,
picking.
that's weird. Great minds think alike.
all right, so 2 and
All right, so
I'll do 1 and 3.
I did. Oh, just kidding. I'll do. I'll do 0 and 2. Did anyone pick 2 yet?
Okay.
all right.
Okay, so 2 points on a graph that each. The second. Okay, so 770 and 1290.
So. Sandy's got the same as what I've got. So 1 and 770 and 4 and 1550. So if we take the difference, Sandy, on ours, if we take the difference in our second value, this is not working out for me today. Our second values, what did we get? Which one did you, how did you subtract yours?
So what I did is I did the 1550 minus 7.7,
Okay,
which was 7.8,
okay,
which then I would do the 7.8 and I divided it by the 4 minus 1, which would be 7.8 divided by 3.
okay. And what'd you come up with?
2.6.
Well, that's weird. And,
Aw.
and let's make sure that we keep our units. Units for this are really important. And this is actually called, if everybody can see my paper, I gotta change my, it's not showing on my screen. I know I'm sharing that, but it's like, sometimes when I go away, press on something else on my screen, then it doesn't actually show it on. So I can see, okay. So we're actually learning how to calculate what's called the slope. And the slope should be able to be found between any 2 points on your line. So that's the fun of it. Did everybody else get 260 for theirs? And they did.
Yes, I did.
Shelby did. Darla, when you divided yours, did you get 260?
Oh, because I didn't know which two numbers to divide it by.
So we subtract the second coordinates, then divide the
Yeah.
result by the difference of the first coordinates. So we're going to do the y's. This is our delta y, we call that our change in y. And then we're going to divide by the change in x. This right here is the change in x. And now you'll see what I did this morning's class is I started with a 770 and subtracted the 1550, but then I just had to make sure that I started with my 1 and subtracted my 4. So whichever one you choose to subtract first, you have to be consistent so that I had to have a negative divided by a negative. So I still got a positive slope, 260. Make sure that Darla's was all good.
Yep, I got 260.
Yay. And so keeping units is very important. So when we talk about the delta y over delta x, that's our slope. I'm going to put units. And so the units of my y were dollars and the units of my x were miles. So notice that we end up with a unit rate, $2.60 per 1 mile, which we worked on unit rate stuff at the beginning of 2.3, if everybody remembers. I think it was 2.3 or maybe it was 2.2. Okay. And we're going to remember this formula for slope. Now, am I concerned about you walking around for the rest of your life being able to calculate the slope between 2 points? No.
Yes, yes, you are.
I'm not going to have 10 of those problems with coordinate points and finding the slope on the exam. I want you to understand what a rate of change is. This is a rate of change. For every mile we go in the car, in the cab, we're going up $2.60. That's what I want you to learn. And we're going to, for the most part, do all this in Desmos, but it's important to understand the workings behind the scenes so that when you go to something more efficient like Desmos, you're understanding what it's coming up with. Okay, so go ahead and move on to number 7. It's going to have us kind of put it to our picture now. Well, you can go ahead and do 7, 8, and 9. Interruption here.
9. Yeah.
So they asked us to plot these 2 points as if this were the number line. And then 8 says, how much more distance was added to the ride going from 1,770 to 5,1810?
Oh, 1040.
So that was the difference in the,
Yeah.
go ahead.
Is that what you guys got?
That's the difference in the, that's the difference in the cost, I think. I think
Yeah.
it's 4 miles.
Yeah,
So,
that's what I,
yeah,
Oh.
so number 8 is 4 miles. And so that difference is 4. And yes, you're totally right, Darla, the difference in the cost is 1040. Good buddy. I couldn't resist.
there.
What did I miss?
The 1040, good buddy. Like we're on the
Oh,
CP.
haha. And I got the slope at 2.6. Did I do it wrong?
No, it's right. Because it should always be 2.6, right? We kind of found that on the front and the difference in the table. And then we found it with our calculation and our formula right here. And then we just found it using the visual on the graphs. So number 10 is yes. 1040 divided by 4 is 260 over 1 mile. So what about number 11?
And 40 is how much it adds.
Mhm.
And the second part is no. Except for your overall cost.
Oh, you found it. Okay.
No, it doesn't matter, right? Because it is the same no matter what. Now, I just want to make
Yeah, I
sure
didn't
that-
think it was going to matter.
and actually, I need to make sure. On the lesson check. So go ahead and keep working for number 12. I just want to make sure I'm giving you the right lesson check. I think we might have already done it. Yep, for those on the video and those on the live, lesson check was on page 161. So make sure you circle 161, number 4, and it's just 2.60. I don't think I have any units on that one.
Okay.
I want to make sure I gave that to everybody. So 13, 12. How could we tell that it was linear?
So it keeps going the same amount.
In what fashion? Adding or multiplying?
Adding, it adds in a straight line.
Okay,
So it's same constant.
okay, so we constant addition between values. Okay. 13 says, estimate the distance of a $16 cab ride, and you can use it, either use the table or the graph, but make sure you explain how you got there.
How far you'd get with $18?
$16.
Oh, 16.
Mhm.
Do they want the exact distance? So it'd be like 4 point some odd miles, or are they just looking for how far they can get with $16?
About 4.5 miles.
You got what? And how
About
did,
4.5 miles.
okay, so Darla said 4.5, and how did how did you estimate, just so we know?
Well,
Do you use a graph or the table?
yeah, I used kind of both.
Okay,
Because 50 gets you 4 miles, so you only need 50 cents more.
okay, that sounds
So if
good.
you look, I mean, you're looking at the graph.
Yep,
I
I'm good
mean,
with
it's
that.
almost 4 miles,
That
and then
estimate.
add a little bit more.
Anybody else want to share their strategy?
Just a little more.
It's probably like 4.2, but close enough.
Yeah, I was guesstimating at 4.1 at first, just trying to guess.
Okay. So
So I just rounded.
that's all right. So I'm gonna share. We can also say, because we have $16.
Ooh,
Huh?
I was just gonna say, I was trying to math it out.
Yeah.
And so if you take $16, you subtract the base of 510, you get 1090. That's how much it costs. So then if I divide 1090 by 2 point.
I'm gonna ask a quick question. So can you tell the audience, why did you choose why did you just subtract 510?
Because that's the flat starting rate. So that's not telling me where I'm going. That's just where I started. So I don't want that because that's not a mileage rate.
Okay, so I pay that.
So
no matter
everything
what.
after that is going by mileage is $2.60 a mile.
Okay. So we have 1090 left to use for miles.
So then I divide that by $2.60 and it's 4.19 or 4.2 miles.
Okay. Okay. Awesome. So we're kind of building our skills. This is fabulous. So we learned that we could use the table and the graph to do some estimating, right, and get pretty close. Or we could use a little bit of mathy stuff, and we're going to kind of build on that. So excellent. Anybody going to take like a 2-minute break, 2-minute potty break, or is everybody good to go on the next little section?
Either.
I'm good too. Well, we'll kind of walk through this, and if folks want to go and take a break, they can. So I'm gonna go take out my contact because my eyes are getting swirly here. So it says, everyone knows that after you buy a car, the value goes down as it gets older. It says, suppose you bought a car for $15,000 a few years ago, and its value has been decreasing at the rate of $2,000 per year since then. Make sure you answer each of the remaining questions with a full sentence. So we have the table to show the values. It's been going down $2 a year ever since that first year. We're going to call that year 0. And then they already graphed it for us. And then we're just going to go through and answer some questions. I'll let you ladies work. So, did anybody find the Y-intercept?
The 0 and 15,000 point.
Okay, 0 and 15,000.
Because
And,
that's where the line crosses the y-intercept or the y-axis.
okay, so we can see it from the graph, great job, and we can also see it from the table, right? Both ways.
Mhm.
It's a 0 value for X, and we can see it in the graph. Okay, and so we're gonna explain what it is. So the y-intercept is the starting value when you purchase the car. Okay. Did anybody figure out the slope?
At $2,000 a year.
Mm-hmm. And is it positive or negative?
It's negative.
Okay. And did you do that with points, or did you just do that from the wording that they told us, or using the table or the graph?
It said $2,000 a year, so that's,
Yep. So
and
they
because
told
it
us-
goes down, it's negative.
Yep, it was decreasing 2,000 per year. They told us there, that's the slope. You could see it here in the graph if you wanted to calculate it that way. Whoopsie. That's another option. Or you could see here in the table, just like we learned in lesson 2.1 with the patterns, right? That you could see it here as well. Okay, so we're going to learn a kind of more of a formal way to interpret the slope. So I really want to follow this. So with every one increase in years, we can expect the car's value to decrease by $2,000. So I want you to explain it as a unit rate, as in I always explain the X first. So as the X increases by 1 as a unit rate with the units, years, we can expect, and then tell me what's going on with the Y, adding in the slope there, the value of the numerator. Okay, can we estimate the value of the car after 42 months? Let's try that.
Isn't it like 3.5 years?
That's what yeah,
42
That's what,
months, 2.5 years.
yeah.
It'd be about $8,000.
Okay, it's the equivalent of 3.5 years. And we could say 3.5 years, right? If it goes down by $2,000. And we add the 15,000, we got approximately 8,000.
Mm-hmm.
Okay, great job. And then what about number 17?
4.5.
That's what I got.
Okay, and where did we get
I
that?
also
from?
got,
Well, because 4 years is 7,000 and 5 years is 5,000. A half a year's would be in there, and that would be 6,000.
Well, there you go. So we work backwards a little bit. I like that. Okay, so that rounds out lesson 2-3. We learned how to find slope using a graph, using a table, sometimes in the story, right? They kind of just tell us, and also using 2 coordinate points. We learned what the Y-intercept was. Awesome. And now, woo, we're gonna move on to 2.4. So that is going to be,
4?
yep, lesson 2-4. It should say this right at the top. It's on page 171, the effects of alcohol.
Sorry. It just makes me think of work.
What do you say?
I said it makes me think of work.
Makes you think of work?
Yes.
Oh, where do you work at? I think it's.
I work at the jail, but
Oh, yeah,
we
you
get a
work
lot
at
of people that come in intoxicated, and regardless of how they get out of jail, they can't get out until they're all zeros, no matter how sober you feel.
Right.
So we have a chart that actually says approximately this many hours if your blood alcohol is this amount.
Right. That's funny.
Except for the people that are professionals, if they're serious alcoholics, they plummet. So they would probably be, dividing or multiplying their slope. They're going down. They don't go in a straight line.
So do they get sober quicker because,
Yes.
okay,
Yes.
because their
Higher
low
tolerance.
their low is higher than everybody else's. Okay.
Yeah, they built up such a tolerance that they need to drink more and more to reach whatever they were feeling. So
Mhm.
then when they drop fast and hard.
What jail are you at again?
Ingham County.
Mhm.
So yeah, like this weekend it was a lot of students from the game.
That's too bad. I mean, I'm all about having fun. Don't get me wrong. It's just unfortunate that everybody's body reacts different. And, some people it is not really allergic reaction, but it is an addiction, and you don't realize how quickly it happens, and affects you. My dad was an alcoholic. So
Yeah.
it's unfortunate because I always worry about like doing anything else just because I have that family history. So I'm like, if I'm okay with just drinking, I don't,
Yeah.
I don't want to get anything else about because it's hard.
It's a slippery slope before you know it.
It is. Yes. Okay, everybody want to take maybe like a 2-minute break? 7th inning stretch. We'll stand up, stretch, come back, and
All right.
I'll let you get started. And I think you guys are going to find this beginning of 2-4 pretty easy peasy. So I'll pause the recording too. Okay, we're back for lesson 2-4. And the title is The Effects of Alcohol, but that's actually kind of like our second group of problems we're going to look at today. And I will share my screen so that we can all work on this together. And here we are. So it says a student organization you're involved in is planning a year-ending pizza party to celebrate another successful year on campus. As chair of the planning committee, you've wisely worked a deal with a local pizza place to provide large pizzas at $9 each. The budget will allow at most $175 to cover the food. And of course, you'd like to know how many pizzas you can get and stay under budget. So we'll attack the problem in several different ways. So I'll let you ladies get started with number 1. And I'm going to have my Desmos open because we are going to use that. And hopefully she'll be able to get hers open if she wants to use it.
I finally got it. I had to close out of it and retry it like 6 times, but we got there.
Yay, persistence pays.
Yes. I was about ready to check the whole computer, but we got there.
Mhm. Okay. How many pieces do you think we can get?
19.
19?
19.
And how do we come up with that?
Yes.
$175
I
divided by the,
divided $175 divided by the dollar amount of per pizza, which is like 9.44 infinity.
Mm,
And obviously you can't buy 0.44 pizzas, so
right. So about 19 pizzas.
yeah,
And
yes.
Darla, you're good with that? On the 19. And some places you can buy per the slice, right? If you go to the mall or things like that, but you're right. We probably can't go and buy a 0.44 of a pizza. Okay, so it says write an equation that represents the total cost C of ordering P pizzas. So anybody have a equation C is our cost? What do we think the recipe is going to be here for the cost?
9p equals C.
9p equals C. Okay. So if we multiply 1 times 9, it'll be $9. 2 times 9 would be 18. We think that will do it. I'm gonna share my Desmos screen and just put that in. So I'm gonna say Y equals 9x. And there's our line. I'm going to zoom in a little bit here. I'm going to zoom out. Okay. Okay. Let's go ahead and flip our page here. It says complete the table, then use it to estimate the number of pieces you can buy. So once you have an equation in Desmos here, I'm going to click on that line where I have the equation. Do everybody see where this gear thing is up here? It says edit list. I call it the gear. If you click on that, it will give you some options for that equation, and a table is one of them. So it's going to take my equation and it's going to put in some x's just like we have here. And it's giving me -2, -1, 0, 1, and 2. I want 0, 5, 10. So I can change these x's and it will recalculate. So 0, 5, 10, 15, 20, 25, and 30. So we could do these by hand, but I want you all to learn how to start using some of these fun tools in Desmos. So we can go ahead and fill in our table there on our paper. Okay, and we have it graphed. So we don't have to graph on here, but it says it wants us to estimate the number of pizzas we can buy using the table. So using the table, we can see that 180 is very close to 175, right? So if we just went down one pizza, that would also kind of maybe estimate where we came up with that 19 pizzas. Then number 4 says use the information and draw the graph, which we already did. So the cool thing is we can just go to our Desmos, and in Desmos, I'm going to say, well, okay, I'm going to, and I was like, wait, the scaling isn't really appropriate for what we have now in our Y2. And where it says 9x. So I'm going to go to my magnifying glass and hit that. And then that makes a little bit more sense on our scaling. So everybody seeing my Desmos screen? Okay. Okay.
Yeah.
So I'm going to go here and I'm going to say, well, let's just say Y equals that 175 that we want it to intersect with. If we go over here and click on the intersection, it will show us where that is. So as everybody see where I'm clicking on it and it brings up the point. So 19.44 equals 175. So it kind of takes away the algebra of it, which is nice. It's good to understand the algebra behind it, but this allows us, you know, a ways of getting at answers that are real life that a lot quicker. So we can see that from there. So if we jump down to number 5, it says, suppose we want to spend at most $175. Now they want us to write it a different way. So at most $175. Write an inequality that can be used to find the number of pizzas you can buy for at most 175. Okay, so I know my cost is equal to 9p. At most, we could also say that that's not more than. Trying to think of other ways to write at most. Over here for a minute. What inequality would we use? We want to compare that to 175. So we have a less than, a greater than, a less than or equal to, and a greater than or equal to.
So we say less than 20.
That would work. But so just compared to this, we want it to be less than or equal to the 175, right? But we can't get an even number of pizzas to be 175. So that's where P is less than or equal to 19.44. So we could say P has to be less than 20 pizzas. We know we can't have more than, can't have even 20 pizzas, so it has to be strictly less than 20. Or we could say that P has to be less than or equal to 19. So we could have 19 pizzas, but it has to be less than or equal to 19. Okay. Somewhat related answer 6 and 7. Looks like you have a helper.
Yeah. I had to take my stuff out of the book so I could get to it.
We haven't seen Darla's dogs in a while. Yeah, Darla, I'm going through a dog withdrawal. If you can help me out. Are they coming in? Oh. Oh my goodness. Is that the biggest one?
Yeah, that's my Soph.
Oh my God.
She's the one that's always in here at my feet.
Oh.
Oh, I'm a girl. The other three love me, but she's mine. Huh. My girl. Huh.
Her name is Sophie.
Yep.
Sophia.
Sophie the first instead of Sophia.
Sophie the first. I love it.
When she was itty bitty, she was always the tallest of all of them. So she would get out of their bed, and the other ones would be crying and letting me know that she was out of the bed.
They were snitching.
Mhm, huh.
Tattletales.
Out of
She's
bed,
like, I
out
just
of bed.
want to be with mommy. So she'd come to my feet ever since she was a baby.
Aw. See, that's what I want you to do, Hazel, but you just don't love me.
Trust
I
me,
got-
I understand that.
This is my schoolwork. Buried.
Her got a kitty on her lap.
I love that our old cat would do that.
No kitty do that.
So what is the slope and the y-intercept of our equation?
$9 pizza.
$9 a pizza is our slope. And what does it represent?
How much pizza we can get for our money.
And where it goes, everyone increase in pizzas. We can expect to pay.
I can't write when you're doing that.
There's more. What is the y-intercept of our equation, our line?
0, 0.
0, 0. If you don't buy any pizzas, you don't pay any money, right?
Maybe.
Oh, look at everybody just sitting there like. Shelby, any pets for you?
I have 1 dog and 3 cats.
Oh. They're
And
general
they're
things.
all not here right now. They're like around. Normally they're up like in my face or at my feet, I guess. None of them are lap cuddlers. I'm not really a lap cuddler either. Like I probably train them that way.
Okay, well, it says, good job, you got your equation and slope and y-intercept, but we forgot to tell you that there's a $10 delivery fee.
Oh, of course there is.
Of course, they're gonna change it.
If I'm spending this much money, there shouldn't be a delivery fee.
Exactly, we're buying all those pizzas. Okay. So go ahead and take the new information and see if you can write an equation. I gotta grab some. And you gotta fill in the table now too. Okay, did anybody get an equation? Did our-
I did C equals $10 plus 9p or $P, 9p.
9p. Okay, and so, or we've been seeing it as the 9p plus 10, but it doesn't matter. They can be flipped around, right? Addition is commutable, so we can flip them. Just in case those at home are worried about the slope being written first. Okay, so now how does that change our total cost?
It doesn't. It just changes the number. Oh, wait, never mind. I see.
Hmm.
The table, I think, should stay the same.
It should. We have that delivery fee though, don't we?
Oh, I guess altogether it should add $10 to each one.
Right, yeah, we gotta, unfortunately, we gotta pay the delivery.
Really, baby? That's right where I need to write.
It'd be 17 pizzas.
So now we only get how many?
17.
Boy, somebody's gonna starve now.
Great.
I got 18.
Plus now I'm hungry and I already ate dinner, but pizza sounds
Right.
good.
Yeah, all of a sudden pizza sounds delicious.
It does. Pizza always sounds delicious to me. Okay.
You can do this one of two ways. You can subtract from the 175 $10 and do 165 divided by 9, it'd give you 1833. Or the 175 over 10, that would give you 17 and a half.
So, well, I think this one seems like our ordering, right? We're going to subtract the thing that's constant, the $10 fee, and then what's left we can actually use to buy the per pizza. So I think this
Yeah.
looks about right. So
Yeah.
18 pizzas.
That's what I got.
Wow, you guys are really good. So this would be 10 and then 55 and then 100
Mm-hmm.
and then 190, 145 in here, 235 and 280. Okay, I'm going to just share with you my Desmos because we are going to find this useful. So in Desmos now I have my red line and my purple here. And my red line is connected, but my purple's not. So what looks different? Then we don't have to draw it on 10 by hand, but and then on 11 here, it says right and solve an inequality that can be, so basically Darla already did that. I'm gonna go back and share my paper. I'm gonna write it. So we still have the cost is really equal to 9p plus $10, and we need that to be less than or equal to 175, right? And then Darla said if we subtract 10 from both sides, and then divide both sides by 9, P has to be less than or equal to 13 pizzas. So what is the slope of the line and what does it represent? And then we have a slope for this one. Is the slope still 9?
how do you get 13 pizzas?
I don't know.
That's what I
why-
was wondering.
I don't know why I said
Oh.
13. I meant to say 18.
18?
I wonder why nobody's answering about the slope. I was like, let's move
We're sitting
on.
going, did we do something wrong?
Well, that's what I'm like. Wait a minute. Mine's, I got Desmos right here next to me. I'm like, it says 1833.
Oh. I'm getting old, you guys. I'm about to turn 50, okay?
You're just keeping us on our toes.
Mhm.
I appreciate you giving me the benefit of the doubt. Okay, so 18 pizzas it is. So back to what is the slope? Did that change?
No,
Our slope is still $9
No.
a pizza, right?
yeah.
What about the Y-intercept? Did that change?
Is that still 0?
Yeah, because you're still gonna get 0 pizzas for $0.
Wow.
Or are we wanting it 10 for the flat delivery fee?
Yeah, even though in our reality, if you don't order any pizzas, they're not gonna charge you a delivery fee, right? But for the purpose of our equation, it is 0.10. So
Okay.
basically, before you even, kind of like the cab ride, before you even go anywhere in the cab, they're charging you $5.10. This is like before you actually order any pizzas, they're charging you $10. See, before we order any pizzas, we are being charged 10 buckaroos. Terrible.
That is just disgusting, I say.
I know it.
You need to get erasable pens, ma'am.
She has them. I saw her friction pen.
Me?
Didn't you have a friction pen there?
No.
I
One
thought
of
you had.
these?
I thought she had one of the click friction
They
pilot friction.
are.
Yeah, yeah,
They do erase, don't they?
yeah.
Yes.
I've never used it. You can
They
believe
have
But not the
highlighters
normal
now,
black
too.
pen.
it takes a lot to erase it.
No, don't.
Uh-uh.
I don't make my.
You gotta use the same pen to erase though.
I did.
That was the pen you used?
Yeah. See what?
No, her pink one. When she
No, you gotta
drew the
erase
group.
the, if you use the pink, you can erase the pink.
I did. Watch. There. I'm turning around the same pen. It is, but I have to press pretty hard. Maybe it's because it's older, and this pen is like 2 years old.
Maybe.
I
They
don't
have
have any-
highlighters now too.
Oh, really?
Yep, got
Highlighters
those
do
too.
the
You
same
can keep a
thing?
pen for 2 years.
This pen? Yeah, I
I
haven't
don't think
seen
I've
my work
ever owned
friends.
a pen for that long.
I haven't really seen my work friends in 2 years, and one of them gave me these pens, which I do have to say I love.
That's the only
I
ones
like
use.
them. I do prefer retractable pens, but with the friction ones, I feel like I prefer the capped ones because I feel like they write better because I think they don't dry out as fast.
Oh.
Oh, I don't have a problem with either one.
So yeah, these are pretty nice. Okay, so 14 says, now here's the key idea. Look back at your answers for questions 8, 12, and 13, and then fill in these pieces.
You'll have to lay down.
That's okay. Mine is laying down all over my book.
I know, I saw it.
Too funny.
9.
Okay. So we're just gonna put this together. So the slope was 9.
So does that make the Y 10?
the Y-intercept was not because it goes 9 and then 10, but yeah, the Y-intercept is 10 because of the $10 fee. Yep.
Yeah,
And the equation was C equals 9P plus 10.
okay,
Everybody's good with that?
yeah,
Okay.
Mhm.
So 15 and 16, we're gonna do just because 16 is the lesson check. So they kind of summed up at the top here, they summed up some things of what we just did with putting our slope and our y-intercept together for an equation. One thing is the coefficient, we call that, is always our slope. It's always the number being multiplied to our variable, like our independent variable, our x. The constant is that value that's never changing, kind of like our cab ride fee to get in the cab ride or the delivery fee on the pizza. Okay, but again, I'm not gonna go through and ask you, what is the constant term or what is the coefficient? It's gonna be, what is the y-intercept? What is the slope? We call the slope and the y-intercept are parameters, okay? They're the things that are kind of like the basis for our recipe, right? And then we can scale them up or scale them down for how big we want the recipe using X. Everybody with me so far? So let's look 15. We're gonna read 15 and then see if we can put an equation to just a story here. Let's throw a couple things away. Can anybody come up with an equation?
If you use P for people, like people I hired, so 4P, or rather 4 people a month, right?
Okay. Yep.
Plus 12.
Okay, so 12, and we'll call that. So why don't we do 4M? So, because it's every month, right?
Yeah, I didn't want to say M because of the slope, and that's what
Oh, right. True. I didn't think about that. On the video I made, I used and then I said E for employees. So I said there were a total however many employees based on, we started with 12 and we added 4 every month. So our
Yeah.
slope is 4. So 16 says, what are the slope and y-intercept? So the slope is 4, and that's all you have to put. This is your lesson check for 2-4. So everybody can do their 2-3 and 2-4 lesson check today. So and then so that means we're growing by 4 employees every year.
month.
Every month, I mean, the company is growing by 4 employees each month.
I peanut.
And then the y-intercept is a 0 12, right? They started with 12 employees.
Yeah.
Okay, and then I'm not gonna do this graph here. I'm gonna show you one last time how to type this in Desmos so everybody can kind of see how to use this.
Yeah.
And then we're gonna move on to this, the blood alcohol.
Yeah, I gotta watch this. Okay, go to my little thing, start my table.
Yeah, and actually, we're not gonna do a table first, but you can leave the table up. You can just go to the next row. Because we have an equation, the 4M plus 12, we can just tell it, we know the recipe. So when we're given coordinate points, you know, a table of data, we're trying to
Okay.
figure out the recipe that goes with the data we have. But we've already been given the recipe. So we're like, okay, if this is the recipe, then how much do I need for one person? How much do I need for two people? If that makes sense. So we're saying how many employees for 1 month. So our equation is going to be y equals 4x plus 12. And I can say, well, I want you to spell it out by scaling down and scaling up. So I'm going to hit the gear.
Plus
Equals
12.
Yep, I'm going to wait till everybody gets there.
4x.
I don't have that icon though.
Hmm.
I don't have that little square.
You had to hit the gear
Yep.
Where?
above.
See
Above,
the
see
little
where your
gear
X.
Yep, right up here, this little gear right up here.
Okay. Oh, all right.
And have it make the table, and then it filled it right in, and we don't have to do anything. We're kind of done with this lesson, but I wanted to show everybody this because this is going to lead us into the blood alcohol content problem. We're gonna jump right in. Now, if you turn to page 176, just so you all know it's there, it tells you how to graph an equation of a line with your slope and y-intercept. It gives an example, but we are becoming so proficient at Desmos that we're crushing it.
Well, that was a new one for me.
Yay, that's good. You learned something new today.
Yes.
Not good. Okay, so let's turn to page 177. And we can kind of read up on the table down below, and Sandy can teach us all.
I have a question. I'm looking at your Desmos.
Uh-huh,
So you put in y equals 4x plus 12, right?
yep.
Yeah.
Okay, because I'm just looking at your graph. Mine looks
because-
completely different, and that's I put the same thing in.
Mine says -2, my x's are -2, -1.
0, 1, 2.
And so let me hit my magnifying glass. It's just gonna adjust my scaling so it looks normal like yours, probably. So right now mine's on 12.
I didn't do the chart part, so I mean, my slope is going a completely different direction.
Oh, so does yours say 4x plus 12 up here?
Yes, y equals 4x plus 12.
Oh, nope, you don't need a y equals. Oh, wait. Excuse me. So my original equation says y equals 4x plus 12.
Hit the gears.
And then I hit the gear and I hit the table.
That's exactly what I got.
Can
I'm
you,
really confused.
you want to share your
I am.
screen? I'll stop sharing mine so you can share your screen.
Y equals 4x plus 12. Okay, so get over here to this so I can share screen.
Yeah, so we can see it.
So you see mine is completely y equals 4x plus 12.
Yep, yours is okay. It's doing it too. So go ahead and go to your gear. It's increasing. It's just a higher slope because of the units that are on your graph. So now hit your
Okay.
table. Yep. And now see on the bottom left, it has the magnifying glass over in the
Yeah,
blue. Now press that and it will adjust it. It'll look like mine.
okay,
Yep.
okay. Yeah,
So,
I'm like, why?
because we just had that really large numbers with the 270, the cost of the pizza.
Yeah,
It was using that scaling and kind of modifying it for our situation.
okay,
Mhm.
okay.
You're good. I'm glad you brought it up though, because you are not going to be the only person that wonders that as a student. So that's good. Okay, so let's go to page 177 and we'll see what we can get done here on this. Share my screen. There we are.
Oh, are you gonna help? You gonna help math?
Sure she is. So this is our blood alcohol table, and Sandy is proficient in this area, so she was talking about this earlier. Okay, so the legal limit in is 0.08, which is actually between here, right? Actually closer to this 0.10. So it's legal to be sedated and slow reaction time, whatever we want to call that, right?
Right.
But closer to the 0.10. So let's look at this person. Of course, it's a girl, of course. They didn't do it.
Of course.
Yeah. So page 178 here says, after being arrested for driving under the influence, a well-known starlet, it might be a famous person. I don't know if kids these days know that word starlet.
Right. Who's that? Do you say
Well,
YouTuber?
We won't even say famous. We'll say influencer. All of this generation.
There you go, influencer.
Influencer. That's what they should have here. Okay. Was found to have 3.5 times the legal limit of alcohol in her blood. What was her blood alcohol concentration? What was her alcohol concentration?
She was drunk. Oh,
She was.
0.24.
Okay, so how are we gonna find that?
Multiply the legal limit by 3.
3.
Oh, I'm sorry. It was 3.5.
So 3.
I don't know how to listen or read.
That's it. That's right. Our folks at home would be freaking out.
all I know is that she was at a level that we would say they need to go to the hospital to get her checked first,
Yeah.
because she's very drunk.
So 0.28%, which
Yeah.
over here, 0.28 is very close to the 0.3. May pass out, tremors, memory loss, cool body temperature. But she definitely had this stuff up above, probably, right? Which we said was trouble walking, double vision, nausea, vomiting. Because they said, what does it mean? So her blood contained 0.28% alcohol. And 3 says, describe some of the effects. So we said possible vomiting, double vision. I got double vision. Take us all back.
You're right.
Nobody wouldn't know that song. Darla and Sandy and I know that song. I don't think
She'd be
Shelby-
lucky if she's walking and talking, truly.
Right, trouble walking for sure.
Unless she's a professional.
That's true. That's true. Okay. So we have John Bonehead. So it's not just a girl this is having to do. John Bonehead decides it would be a good idea to drive when he shouldn't. Fortunately, he gets pulled over before anything tragic happens. He's
I
not
really
gonna
love the
have-
lesson they put in there.
Huh?
I love that they're putting a lesson in there, by the way.
Right. And it says, fortunately, he gets pulled over. Well, he's not going to think that, right? Because he's going to get a big fat ticket and go to jail, and do not pass go. But it is because something tragic could happen. And we do want to prevent that. He has a BAC test that says he has a level of 0.16 at 2 a.m. Unlike most other drugs, studies have shown that alcohol leaves the bloodstream at a constant rate. Table shows his BAC every hour after the arrest. Okay. So I am going to go to Desmos, and we are going to come up with the equation and everything using Desmos. So,
Okay.
If everybody wants to go to Desmos. Well, before we go there, I'm gonna write on my paper what I'm gonna type in. Let's just write this. If you think you have a linear model in Desmos type, and then my data is going to be in Y1 and X1. So whatever your Y says, use that number. Mine says Y1. And then you have to use this symbol. It's called a tilde or tilde. And it is the key to the left of your number 1 key. Now you can use the keyboard in Desmos, but it's clunkier. So you'd have to do shift and then that key to the left of your 1 key. And then you're going to tell it and then you're going to say, I want to use X1. So I'm using the values in X1 to predict Y1. Okay. And so let's label it down here. The hours after 2 a.m. here, that's going to be our X1. And the BAC level is going to be our Y1. And then we have to have Y1 tilde MX1 plus B. So we want Desmos to give us the slope, which is M, and the Y-intercept, which is B. And you can call them, you can say Y1 tilde AX plus P if you want. You can give them whatever letters you want. I'm sticking with M and B just because for all of us that were scarred back in college or high school, which maybe I should have used other letters because we were all scarred back in high school, but everybody probably remembers M and B. So I say for all intents purposes, let's just use M and B. Okay, so now I am moving to my.
More bubble gum.
Oh, geez, what did I do over here? Okay. Okay, so I'm going to create a table.
Oh.
And now we have parts to your recipe and we're trying to come up with the whole recipe. We have pieces and we're like, what does this make anyway? So I've got 0, 1, and it knows to repeat. So I can just keep hitting enter and it will go to 4. And then I'm going to enter my 0.16, 0.145. Okay. And then because of the scaling that was previously up, it looks like all the dots are on the bottom, but I'm going to just hit my magnifying glass and it will readjust. And does everybody's look like this? It's going downhill.
On mouse, where'd you go?
Okay, so
Darn it.
we're going to type in the model that we think, because we think it looks linear. Does everybody agree with that? We think it looks like a line. So and notice everybody should look up what their X1 and Y. Mine are X1 and Y1. If yours are not, you can rename them X1 and Y1 if you want, or you can just use the values or the letters that they have up there. But I'm going to say Y1, that tilde symbol, MX1 plus B. And then it automatically gives us these values here.
Okay, stop it.
So the parameters down here at the bottom where it says parameters, M is our slope and B is our Y-intercept. And I'm going to just copy those to numbers 4 and 5 on my paper for a moment before we talk about them.
All right, so you typed it. Okay. You are so not helpful. Thank you. Oh my goodness.
It's on their time.
Yeah, sure is. I can't even find the tilde.
On your 1 key, is it to the left of your 1 key? Mine is,
No.
but not everybody's it might be set up a little bit different.
Is it on your number
There we
track?
go. I found it. All right, so now I can go back and let's see here. So
Shelby, you're grinning.
why?
My husband tried to sneak behind me, so he like ducked down, but you could definitely see him. So it was like way funnier than had he just walked past.
Her
My
husband.
husband, he was trying to sneak past into the kitchen, but he should have just walked behind me like normal.
Your husband?
Yeah.
Mine is always like, I don't want to be on the Zoom.
Yeah, that's what mine was like. Why would I want to be on? Because it's cool.
So everybody got the same M and B that I got?
Yes.
Plus,
And
Yes.
then I want to go over again with the R equals, because the more I go over it, it'll sink in eventually. The R right here where it says -1, we want that to be 1. That tells us it's a perfect linear. It's a perfect model that we chose. So the model we chose was linear, and this is a perfect one because it says it's a 1. And the negative tells us that our slope should be negative. It's going downhill. Okay. Now we're
Okay.
going to learn how to do an exponential model like we did this Y1 tilde thing. We're going to learn that in lesson like 2.6, I think, 2.5 or 2.6. So the cool thing is we know what an exponential looks like, right? It's a multiplying, and we talked about that with that compound interest back in lesson 2.1. But we're getting it. It's going to be one little addition thing here to this, and we'll be able to do the exponential model. So this is a perfect fit because the R is a -1, and there's our M and our slope. And so let's go to 4 and 5 and write those down and discuss what they mean. I'm going to share my screen back to the paper.
all right, so this slope is
Okay. So our slope means for every 1 hour after 2 a.m., right? That was the initial time when it got picked up and tested. John's BAC will decrease by, and we'll say approximately 0.015. And I don't think there's any units on your BAC. Oh, percent. It's percent.
percent.
Percent. We got it. Okay. Are you with me on the slope? And the Y-intercept is 0, comma 0.16. And it tells us
That's where you started.
what John's BAC was at 2 a.m. when this all went down. Everybody doing okay so far? Sylvia, you're good. Darla?
Yep.
Okay. So we're gonna flip the page to page 179. And it says, write the equation. X is remaining hours or representing hours after 2 a.m. and Y is representing BAC. Well, we already know this. It's Y is equal to -0.015 X plus 0.16.
Yeah, she was harassing me for my entire class.
Was she really?
Well,
I thought
yeah,
she
they
was-
all got to see her.
Yeah, get your kitty.
You're still in your class?
Yeah.
Okay.
We shared.
Good.
Okay.
Got to see other kitties and dogs. So.
So 7 is just basically wanting us to write out kind of like what the equation represents. So if X represents, and we should be able to say what X and Y represent. So X represents time or hours, right? Hours after 2 a.m. Then Y represents his BAC.
Blood alcohol. Yeah.
Yep. And so 8 is just talking all about graphing and how we can use that, which we've already put it into Desmos. We're a step ahead. We've already seen the graph. We're going to use that in a minute. So 9 says, what would Mr. Bonehead's blood alcohol concentration be at 3 a.m.? And then it says,
3:30.
remember, eating greasy food won't change it.
Mr. Bonehead, I love it.
Okay, so 3 a.m. is how many hours after, oh, 3:30 is how many hours after 2 a.m.?
That's 1.5.
Okay, so 1.5 hours. So you could either put it into your equation as X, and you could solve in Desmos if you wanted, our equation at the top of page 179. It's not cheating, but I am going to use Desmos because I want to show you how efficient it is for all the people that were afraid of algebra. We can go right here to Desmos, and I'm going to just grab onto my green line and see how it just made a slider for me with hold down your left button, and it will slide up and down. And I want to go to where X is 1.5. So I have to go up, but it's because my X coordinate is changing and getting smaller. So 1.5, and there, oops, there, yeah, there it is.
You're so close. Oh,
Oh, it's so close, but yet so far. I can't get it
like I
right.
saw you hit it.
I
when you
didn't,
went
didn't
to-
I? Oh,
Oh,
I got it.
there you go.
I'm a
She
winner.
did it.
So I'm not gonna move it for a minute. Does everybody have that? So at 1.5 hours, his blood alcohol content will be 0.137. BAC 0.138. We should round it. Oh no, 0.137. Yeah. Percent. Too funny. And then number 10 says, how many hours would it take for his BAC to drop below the legal driving limit of 0.08? So this, you can, when you have a Y that you want it to cross over, you can go over here to a line, make a new line entry in Desmos and just type Y equals 0.08 and hit enter. And then notice down here, it gave me a new line at 0.08. So we see that. I'm going to zoom out a little so I can
Mhm.
make sure. And I can just go and click on where the intersection is. And there it is. So it equals
5:30.
You're at 5.33. So about, 5.33 hours after 2 a.m. So 5.33 hours after 2 a.m. So about 7 and 0.33 is a third of an hour, right? So it's really about
20 minutes.
7 a.m., 7:20 in the morning. Okay.
Mine took my slope away and I don't know where it went.
Oh, it took your slope away.
Took my green line away.
What?
Yeah, I don't know what happened.
Can you go back up and click on your line?
No,
Did your color go away up here in one of the circles?
nope.
So see where it says Y1 tilde MX, is that still there?
Yeah.
And then is your, right here, see where I'm pointing where mine is green over here in the circle? Oh, let me stop sharing so I can see yours again. So put up your screen. Okay, there's that. Okay.
Yep.
Now, oh, I know. I bet it's your scale. It's your scaling, hun. So go hit your magnifying glass up on your table. It worked. Yay.
Yeah.
Winner, winner, chicken dinner.
I'm like, where did it go? Stress, stress.
We got it. We crushed it. Okay, so I'm gonna go back and share. We are almost done. If everybody bears with me, we'll get this rest of this part of the lesson done and we'll be good. And just a reminder to everyone that I'm not doing the extension problem. You already have the lesson check, so I'm not doing the extension problem at the end of the lesson. It is listed on the problems on your, schedule sheet for 2-4. If you want to go do them, I made a video that's in the YouTube link. It's just more practice. But I'd really like us to move forward into 2-5 on Thursday. Okay, so number 11 on page 180 says, what information would you need in order to draw the graph? Well, we've already done that. So we're going to skip 11 and 12. And then it says, what is the X-intercept? And what does it mean? And we've already looked at that, right? Didn't we already do that? And yeah, the slope, number 4. Oh, it says, what is the X-intercept? My mistake. So what is the X-intercept? So remember on the first equation with the, or the first scenario we did with the cab, we said there was no X-intercept because we couldn't go to negative miles.
Oh,
So
yeah.
the X-intercept is the X value when Y is 0. So we can go to our graph in Desmos and say, I want my graph to equal, instead of 0.08, I just want it to equal 0 and hit enter. And then, or we could just follow the green line down to where it's 0. But I'm going to click on it and there it is. So it's going to take John well over 10.5 hours, right? Before
Sounds about right.
Huh? Does that sound about
Sounds
right?
about right.
Sounds about right?
Yeah.
10.5 hours before has no blood in his concentration and his no alcohol blood concentration. Blood alcohol concentration. Geez. So approximately 10.67 hours. So John needs to wait in the clink for a while. Well, he can leave at 0.08, can he?
Not in ours.
Oh,
Liability. You got to be all zeros.
So he's not making it home until after lunchtime.
Yeah. He's going to have some splaining to do.
Some explaining to do. You're right. Okay, so we can wrap it up here with questions 14, 15, and 16. I'm going to go back to our paper. You all are doing awesome. They give us some connection up here between slope and direction. So I'm going to let you all draw. Fortune says draw a line with a positive slope, draw one with a negative slope. And what do you think a slope with 0 would look like? So I'm gonna let you draw those and then I'll give my example. So a positive slope, I'm gonna draw in blue and pink. So this would be my positive slope. It goes uphill is the way I think of it when I'm reading like left to right. So everybody on that
Yep.
one. And all of these pink ones would be considered positive slope. Even though it's sharply positive, even though this one is barely positive, those would all be considered positive. Now, something with a negative slope could be as sharp as this, right? It could be shallow or shallower, but those are all negative slopes. And then I'm going to draw with my green marker. A 0 slope is kind of like just walking across the room, right?
Oh, okay.
Or it could be down here, but it's still going to be flat. Wow. We have 5 minutes to spare. So everybody has the lesson checks right for 2, 3, and 2, 4. You're good with those. So we're gonna start fresh with 2, 5 on Thursday. And like I said, I'll keep that extension problem if we want to go back and do that later, but if you all want to go back and do that on for your own for some practice. The 2, 3 worksheet takes a little bit longer because it is 3 pages. There was no 2, 2 worksheet, that's kind of your reprieve a little bit. Any questions for me?
2, 3, is that the blue one?
I don't know what color your worksheet is. Is it blue?
Yeah.
Okay. Yeah.